Welcome, party people. This is part one of the Matlab for Sports Science kind of video tutorial series I'm going to do. We're going to start this first video with single trial processing, so starting kind of from the floor and then working our way up eventually to processing all trials at one time. This is a good place to start. It's where I got my start and kind of helped me get along with using Matlab for force platform analyses and even further things with marker trajectories and combining those two things together all in one place. So what we're looking at is the main Matlab window once you open it up. The main thing to be aware of is where Matlab sets your directory. So the directory is where everything is located that Matlab will use, whether that be saved Matlab programs that you have. You'll see I've got a couple of random ones here that I just kind of screw around with, but also other things like your Matlab functions. And functions are things, actually I have those in a folder here. Functions are things that you may end up using frequently that are longer kind of programs in themselves, but you want to be able to call those in one single line. And it's kind of beyond our needs for what we're talking about here. I will reference a function or two when we get down there, but I'll show you where you can locate those functions as we get there. So what we need to make sure we do is set the working directory. Matlab will always open typically where the program is saved. So mine opens in my profile with my documents and then Matlab. I got to make sure that everything is in the path. So when you open this up, if any of these folders or plate locations that you have are gray, they're not in the path. So even if you have a function or you have a code, a script that you've already written, it won't work unless you add everything to the path. So I'm just going to highlight all these and just see I've got these. They're already in the path. So instead of here remove from path, you would add selected folders and subfolders, and then everything will show up like it is. Now we're starting with a fresh screen. This here's the command window, so I can just start doing things in here, like I can just start typing in things like a calculator essentially, and here is where those things get stored in the workspace. This is useful for when we're building scripts and we want to check their functionality, but what we'll always do is start a new script here. And so I'll do that, and mine pops up here in the top. Yours may have a different layout, but this editor is where we're going to edit those scripts. Anything I type in the command window, right, if I did something simple, right, that'll still pop up in that command window. Okay. But to start that script, let's work in the editor. Now the first thing we'll always do when we write a script is we will clear. That's going to clear the workspace, and adding that semicolon suppresses the command. Because if I don't, see, these were not suppressed in here, so it gave us an answer, and I'll show you what I mean by that. So if I do 1 plus 1 again, it gives me all this information. But if I do 1 plus 1 here and I suppress it, it doesn't give me any of that information, and it still stores the answer. So since there are things here in the workspace, we're going to clear those. And see, if I just copy this from the script and paste it into the command window, it will do that. See, that clears the workspace. Right underneath it, we'll hit CLC. That is a clearing of the command window. And so if I do that, you'll notice here in the command window, everything wiped away and starts clean. Okay, so that's the first thing we'll do every time we write one of these scripts. Another thing I like to do is close all figures. So if you do close with a space and an all, that will close all the figures. We don't have any open, but it's nice to have there. Okay, another thing I like to do is turn off warnings, because Matlab will give you some command window text if there's something that you can do better or more cleanly, and it'll give you those. So I like to suppress those here with warnings off. So that's kind of the first bit of here. Now when we write these scripts, I can create sections and title these sections. So if I do 2 percentage signs, it will let me create a section. If I do 1 percentage sign, it will let me add notes. So that's pretty important. So you can do whatever you want to here, and those notes will not run in the script. So what I'm going to do is clear workspace, and then what we're going to do is also set the working directory. So the working directory is where all your folders are stored for all your files and trials that we're going to work with. So here's where we're going to set the directory. So I'll put a note here so I know that those are what those lines of codes are. And what I'm going to do is set the directory using a dialog box that will pop up using a Matlab function. So I'm going to call my directory mydir. And you can call it whatever you want to. You can call it Fred or Steve or Joe or whatever, but I call it mydir. And this is going to be called UI-get dir. Okay? And that is a Matlab built function, and it will open a dialog box so that you can select the working directory. Okay? And so if I were to just copy that line, okay, it'll pop up this dialog box. It says, okay, where is it going to go? Now you'll look here, the folders that are open, it's going to ask you to locate them here. It defaults to wherever you're sitting in your directory in MATLAB over here in the current folder. My files that I'm going to work with are not saved there, so I'm going to go ahead and just locate that folder where I have these trials saved. Okay, so that's my directory, and you'll see here it comes into the workspace. Now what I'm going to do is establish my files. Now if I were to open this a Finder window here and go to where I have the files saved, it's important to know exactly how we've got them saved. So when you collected the data, it's important that we know, if I do the type here because we want just the text files. So you can see we've got isometric mid-thigh pull data, so IMTP with the date and the trial number. I've got counter movement jump 2, that's a double counter movement jump, and then we've also got just single counter movement jump data, and these are what we're going to end up using. So we have to make sure we know exactly how these are saved when we work with single trials or when we're trying to call these as a group. Okay, so what we're going to do is I'm just going to pull this off to the side because we don't need it. But here I'm going to have my files, and I'm going to organize these files using a Matlab function called the directory, so dir. And we're going to pull the full file. This is a full file kind of extraction of the entire name of the file and everything. They're going to be pulled from my directory, which I've called mydir. And the name of those files, if you recall how I had them saved in the folder, would be cmj underscore with a date. Now what I'm going to do is use an asterisk. An asterisk is a wildcard character, meaning that anything that's in that place is going to get pulled. So if I've got trials that I've organized by multiple dates, that's going to be useful because those will get pulled in there too. All right, so we'll do the wildcard and then the trial. And I've got trials that go from 1 to 5, so I'm going to put a wildcard here instead of a number. All my files are txt, so I'm going to use a .txt. Okay, and what I've got to do here is put those into single quotes. So you'll see the single quotes will turn that into kind of that purple text. That's how we'll enter in kind of what they call string data or character data. I will then have to, because I've got one parenthesis here and one parenthesis here, I'll have to close those out. Okay. And what this is doing is locating all the files meeting the naming criteria. So if I were to copy this line and put it into my command window, right, I'll have this new workspace folder called My Files. Now you'll see I've got 15 files here, And if I just look at the name, so when you think about what was happening here, this full file, all that stuff, is it's pulling every piece of information from that file that it has. What I'm concerned with here is the name. And so you can see I've got CMJs with the date that they were collected and the trial number. So there's 5 trials collected on this date. The next date is here, there's 5 trials, and the next date here, there's 5 trials. So when we end up getting to analyzing multiple sessions, we'll end up having 5 trials recorded across 3 sessions. For this, we're only going to deal with working with one of these trials, but it's good to just set that up in case we wanted to have it. Okay. Now, our next bit is going to be to import the trial. Now, a couple of these lines are going to be useful, especially when we get to working with multiple trials. So that's why we're going to have them here. And so I'll put my note here to say that these lines of code are going to import the trial. All right, now we're going to do a line called base file name. Oops, gotta be case sensitive here. And we're going to make that equal to my files. So what I'm looking at here in the workspace, they're going to get pulled just one, meaning I want the first trial, and I want to pull the first trial from that name column. Okay, so that's what this line is doing here. All right, and if I do this, we'll end up with a new line here called base file name, and you'll see if I were to type that in the command window and not suppress it, there's the base file name. So it's just making sure we have this known, okay, because that's what we're going to end up importing here. If I wanted to do the second trial in that list of my files, so if I wanted this trial here, I could just put a 2 in that parenthesis, and then you'll see here in the command window, it pulls that second trial. Okay, but we're just going to work with the first one, and there we go. So our next line in the command is going to be to create a full file name, and these next 2 lines are really just for spice, for added flair in the code. So technically, you know, we could probably get away with not doing them, but I like to add these in, especially for when we run the multiple trial option here that we'll get to later on. So we'll create a variable full file name. We'll use a Matlab function called full file. We're going to pull it from my directory, and we're going to use the base file name that we just ran in the line above. Okay, and what this is going to do is build a full file name. Oops, if I can type it. A full file name from the parts. So the parts of the information that were imported here in my files. Okay, and if I do that without suppressing this, you'll see it puts together that full file name. Every piece of information we've got on there. All right, now the next bit is another also a little piece of flair. We're going to use Matlab's function called fprintf, and what that's going to do is put a display in the command window telling us something that we want to do. So here I'm going to go fprintf. It's going to be one line, and we're going to say now reading. Now, in order to display this on the line correctly, we have to do a couple of things that are kind of beyond digging into why. But what we'll have to do next after this space is put in a % with an S and I believe that one's a backslash, right? And an N. So what that's going to do is allow things to kind of move on to different lines or organize them appropriately. And then we will use full file name. And so what this is going to do, this line, is display that the file or files, depending on what you're working at, are being read by the program. All right, and so if I just were to run this here, you'll notice it runs and then it says now reading, right? That trial. So I know what trial I'm processing. And it's just kind of a good double check, because if you're going to go through these and have like 30 trials that you're going to do one by one, and you go through it, and at the end you go, man, what trial was that? Well, you know you've got it here because it's displayed. Now the next bit is to import the actual numerical data from the trial. Okay, so this one here is, I just keep it simple, and I call this num for numerical data. You can call it wherever you want to. And we're going to use Matlab's import function called read matrix. And what we're going to do is read in the full file name. Right, and so what this is going to do is, this is actually the importing of the file. Okay, and if I were to run this here, we'll open up this file, and here's that numerical data. Now, it's important to know what these columns represent, because that's for your specific file. One thing I always like to do is I'll open up in here and just open up this first trial, and I'll open it in Excel because it gives you a visual of the trial that you're working with just at the very beginning. It's kind of useful to have. So obviously this is kind of a unique file. Any of you who are working with AMTI NetForce software to collect your data will recognize this. You know, it's a comma separated values file, but we'll know what columns here correspond to what pieces of data. So that's important to know for your trials. So make sure we understand what columns these are, because it's going to be very important when we extract the data here in a second. All right, let's get some space here. So trials imported. Now what we're going to do is extract the numerical data. All right, so this has a triaxial force platform, so it has 3 axes of data. I won't necessarily use all of those, but it's good to know how we'll pull those out. And so for my file, the orientation of the user on the force platform kind of rearranged things a little bit. So if you think about the coordinate system of the force platform, and the long axis going forward being the Y, our athlete in this case was perpendicular to that, so the anterior posterior is actually the medial lateral data. So we had to jot a note that down so that the force in the y-axis is actually where the force platform is exporting its x data. So hopefully that makes sense there. But what I'm doing here, I don't know why I said mean here, I'm not calculating an average. So Fy, so F anterior posterior, is num, so it's from this numerical data. And we're going to use a colon here to say all of the rows. So we're going to pull every single one of these rows. If you look at right here on this little piece here, highlighted, there's 6,000 rows by 6 columns. So the rows get called first, and if we did the semicolon, it says pull all the rows. If I wanted to pull a certain selection, I can do like 1 to 5,000 if I wanted to ignore some of those. But I'm going to do all the rows, and it's going to be column 1. Okay? And then I can just give this a note. Okay, and now if I run that, my Fy will go into the workspace. All right, so there's the Fy data all here. If I wanted to just quickly look at it, I can grab this column, come here to plots, plot it, and it creates a little plot of that anterior posterior data. Now I'll quickly do the next for x. Now this is actually the column where medial lateral data, or excuse me, where anterior posterior data should be, but again, because the orientation of the athlete, it changes here. All right, so all of the rows of the second column, and then FZ, the one that we really care about, is the third column. So it'll be num all of the rows of that third column. Okay, and then while I'm at it, I'll just add here what the sampling frequency was. And these were recorded, oops, don't need the hertz, at 1000 hertz sampling rate. So that's going to be useful for us. What I'll do is just run those lines here. And then what I'll do is I can just look at the FZ data. If I click it in the workspace and then do a quick plot, you can see there's my force trial or force curve for that trial, which looks pretty standard, I think, to what we would record. All right, now the next bit for us that will be kind of useful is whether or not we want to filter our data. I will err on the side of yes, but you know, that's kind of your strategy. If you're not going to do the filtering, you just leave it here. So if we're going to do some filter parameters, we have the sampling frequency set. The next thing we need to do is normalize the cutoff frequency. If you're unfamiliar with this, you can Google how to build a low-pass filter in Matlab. It's actually quite a simple process. So first thing we'll do is do our cutoff frequency. Here we'll do a 50 hertz cutoff frequency. And to normalize that frequency, we're going to have to divide that by half of the sampling rate. Okay, so 50 hertz divided by half the sampling rate. This will normalize the cutoff. The next bit will be to create filter coefficients. So you can call these whatever you want to when learning these MATLAB tutorials and stuff. Calls them B and A, so I just stuck with that, but you can call them anything you want. We're going to use a butter. That's a MATLAB function for a Butterworth digital filter. Here's where you specify the order of the filter, and we're going to call this a fourth order. Now this means it's going to be fourth order before the filter goes through. Okay, so there's a publication that I just wrote that you might want to read about if you're thinking about, okay, how do I want to do this? Do I want it to be a fourth order filter with it set before the passes, because this will be a bidirectional filter? Do you want it to be after the passes? Because those kinds of things are changed here. So we're going to do fourth order before the passes, and we're going to use that normalized cutoff frequency. Okay, so what this is doing here is determine the filter coefficients. If I can type it, for a fourth order dual pass. And again, remember the order and cutoff set before the two passes. All right, now the next bit is going to be to apply the filter. Now I'm only going to apply this to the FZ data because that's really what we're going to focus on, but you would do the process the same for the Y and the X data. So here what I'm going to do is do FZ. Now even though this FZ already had a name from the previous one up here, that's okay. Here it's going to overwrite that and use this new line. Now MATLAB has another built-in function called filt. Okay, that is going to apply the Butterworth filter function, so we don't actually have to code anything too complicated. But what we are going to do is use those coefficients that we used before, and we're going to apply those to the FZ data. So this pulls the FZ data that was here, it renames it the FZ here. So it could be a little tricky in terms of what you're pulling in, but we're just overriding that one. And so this is filter the FZ data. So if I were to go here, and let's just do a little tricky plotting. So in the command window, I'm going to plot my FZ. All right, so that'll default to plot in blue. What I'll do is filter it and then plot that here as well. There won't be a whole heck of a lot of change. But if I were to do that and I would plot the second line on here, I would do a hold on. That's going to tell MATLAB, hang on, we're going to plot something else on the figure, so don't override what was in the figure. If we don't put hold on, it's going to just plot on top of that and remove the other one. So we'll do that. We'll now plot the new FZ. I'll change it with a comma here and a single quote, and I'll give it a new color. Let's give it red and plot that. So that will be here. And so if I maximize this, you can see not a whole lot has changed here in the jump, right? But when we get to the landing, some things started to become attenuated around those peak magnitudes. So again, filtering, that's up to you. Kind of a methodological art form there. Okay. But now we've imported our information. We've imported the trial.